Hello everyone, this is Flora and this is my UNIX lab experiment number 4. In today's experiments, we'll be doing base conversion using shell scripting. There are 5 sub-problems to this experiment. First one is decimal to binary conversion. In decimal to binary conversion, our input would be a decimal number and the output would be a binary number. So basically, we'll be taking a decimal value and then we'll be dividing it by 2. And the modulus, that is the remainder, would be stored in a variable. We will keep on dividing the decimal number and finding the modulus until the decimal number is 0. Next, if we execute this, it will ask us to give by a decimal number. So if for a decimal number, say 10, the output would be 1010. So basically what it does is it takes 10 and then divides it by 2. The remainder in this case is 0, so 0 is stored. Next, it divides the quotient, that is 5. It further divides by 2, finds the quotients. This process is continued till the decimal number is 0. Next is to find binary to decimal number. So for binary to decimal number, the user would give a binary number as input, and then suppose for 1010, the place value for each bit is divided by 2 raised to the place value. Suppose for the last bit 0, it would be 0 into 2 raised to the place value, that is 0. And similarly for the second last bit, for 1, it would be 1 raised to 2 to the power of the second place, that is bit 1, so 2 raised to 1. So all the bits values would be calculated and will be added to find the decimal value. So when we execute this, it will ask us to give the binary value and the resultant would be a decimal value. For example, for 1010, the decimal number would be 10. Next one is to find octal to hexa. In octal to hexa, it will ask us to give an octal number, and that octal number will be multiplied by 8. Suppose if the value encountered is either from 10 to 15, then the hexa value for it, either A, B, C, D, E, will be replaced and that would be given as the output. So if we execute this code, it will ask us to give an octal value followed by the output would be. So if you see, when we execute this, it will ask for an octal value and then the resultant would be a hexa number. Next is hexa to octal value. So what we have to do is we have to convert a hexadecimal value to a octal value. So the hexa number is taken from the user, and then if it either falls in the range of A, B, C, D, then we replace that value with 10, 12, 13, 14, so on. If not, then we divide it by 8, finding the modulus similar to decimal to binary conversion, and that would result us in the octal value. So when we run this code, it will give us the desired output. For the next experiment, that is to find decimal to hexa. For finding decimal to hexa, we'll be giving the user a decimal value and which will be further converted to an hexa value. So for example, if our decimal value is 10, then it will use the switch case to find if there is 10, then it will represent the hexadecimal representation of 10, that is A, B, C. If not, then it will divide that value, the decimal value, by 16, and the desired would be the hexadecimal value. So when we execute this, it will ask us to give us a decimal value, and then the resultant output would be a hexa number value. So if you see, for the decimal number 10, the desired hexadecimal number is A. So that's all for the experiment number 4. Thank you.